Hi there. You've probably heard of black holes before. You know, those giant holes in the universe that suck everything in, even light? Well, the crux may be right, but it's not a complete definition. You see, a black hole is more of an area where gravity is very strong. Actually, black holes are not even holes, even though they're named as such. They're, in fact, a ton of matter packed into a very small space. Yes, an unbelievable feat, if I may. Now, even then, this definition requires some more further elaboration. Like, sure, it's dense AF, but like, why does that matter? Well, it does. Alright, here's the thing you can go near a black hole, but there's a limit. Now, that limit is what I decided, Wolfgang Grindler decided, to call the the event horizon. This is a fascinating boundary that it's basically the marking of where an event can no longer send signals or information out to the universe, including our good old light. That means that neither you, I, nor Epstein can see what happens after an object or info passes through it, and the thing inside the hole after the horizon cannot see the universe outside. Pretty scary, ain't it? Luckily, there aren't any nearby, and the closest one is Gaia BH1, located 1560 light years away. Yeah, light years. Not too far away, yet not too close. Now, the formation of black holes is very interesting. How it works is a star dies. Yes, quite sad. But it doesn't have its own funeral, and it is definitely not buried sitting on its Harley Davidson in a graveyard the size of a $1 million studio in New York. Call it a penthouse at that point, am I right? Anyway, how a star dies itself is intriguing. So you know how tug of war works? Yeah, it's that basically, but permanent. A star fights an internal battle all its life, and that too for imminent death. Ghastly, I know. The two forces that play this deadly game are nuclear fusion and the glamorous gravity. Gravity is pushing in harder than CGP protests, and nuclear fusion pushes outwards, trying to balance this force. And it works. Well, for a while at least. For many, many years. But eventually, man, the fuel runs out. The force is too much. The gravitational force is too much for the star to take, and it decreases, becomes smaller in size. The core of the star, which is basically iron, which cannot be fused into energy, collapses into itself, and then it releases an astronomically gargantuan explosion called a supernova. Excuse my German. This leads to either the formation of a very, very dense neutron star, which are cool in its own way, I'll explain those in a future video, or the Great Black Hole. Yes, very cool, I know. Even Schwarzschild agrees. And he's a dead man, a legendary one at that too. Now, as with all the discoveries of new things, there are misconceptions. A lots of them. People think that black holes suck everything up, irrespective of mass and size. But that's a bit wrong actually. A black hole in reality only exerts gravity due to mass. Mass is fundamental. Hell, if the sun were replaced by a black hole of the same mass, guess what? Earth would not be sucked inside. But we'd be, dead in a few minutes. Cold and cripples, all that. Yes, mind boggling. But true. It's just that gravity depends on mass and distance. So, yeah, black holes are just like every other object in the universe with some mass, if you're far enough away, that is. Now, someone may ask, but how do we prove that black holes exist? Well, god damn it, we just need to look at. Yeah, we had to do some very sciencey stuff. I'll explain. Scientists, they kept on seeing large celestial objects like big stars getting pulled by some unseen mass. Scientists were baffled, so they observed, they experimented, and in 1971, the first black hole, Cygnus X1, was found. It was an astronomical discovery, pun intended, if there is one. And sadly, it wasn't captured on camera, but it was rather felt. X rays came from Cygnus, which helped in the proving of its existence. Black holes actually heat up materials around them, which then emit such rays, during acceleration and collision of black holes. Yes, I know, very wondrous. And also, third, our proof was further exemplified when the first picture of a black hole was taken in 2019. A very historical moment for all of humanity. And that too of Messier 87, located in the galaxy called, guess what? It starts with M, ends with 7. Haha, Messier 87. What a funny joke. It looks so weird, but so awe inducing. It makes me want to dipole. These are just three proofs and existences of black holes I've stated here. But there's obviously better in depth explanations out there too. I've just, shown the very basics. Alright, this is the big funky mess that's the reason scientists are fascinated by black holes. This is basically one of them, and it's called time dilation. Now, at first, that phrase may not make sense to a lot of people, and probably won't, because it literally means time slowing down. Yes, you heard that right. The slow down of time. The time is affected, changed, bamboozled. Guess what? Bamboozled by black holes. All due to their gravity near a black hole. Sorry, all due to their gravity. Near a black hole, time passes slower than the outside universe due to the insane gravitational force. Time is bent by gravity, time and space. Imagine two people. One stays far from the black hole, one stays far from the black hole, one travels close to it and then returns. The person who went near the black hole might find that much more time has passed for everyone else. To them, the trip may have felt like hours. For the outside world, it could have been years. Yes, years. Okay. To conclude, no, black holes aren't just giant cosmic vacuum cleaners waiting to swallow the universe. But honestly, the truth is even weirder. They can trap light, distort time and space itself, and contains some of the most extreme conditions we've ever found in nature. And the craziest part? We still don't fully understand them. Black holes remain one of the biggest mysteries in the universe. Just like philosophy, just like life, just like universe, everything. And that's what makes them so fascinating. If you learned something new or enjoyed this video, feel free to like and subscribe. It would help out a ton. Thanks for watching. Oh god.